A single, isolated planet faces a persistent mathematical risk, the sudden, catastrophic wipeout of its only intelligent species. Physicist Enrico Fermi highlighted a contradiction now known as the Fermi Paradox, the high statistical probability of extraterrestrial civilizations versus the total lack of evidence for them. This suggests the existence of a great filter, a threshold that destroys life before it can leave its home planet. Public analysis often categorizes Elon Musk's focus on Mars as an ego-driven vanity project. Critics point to the immense cost and frame the mission as an eccentric billionaire's hobby. Yet the engineering specifics tell a different story. The mission functions as a specialized insurance policy, a structural mechanism to back up human consciousness on a second planet. Musk's separate corporate entities operate as the modular components of a single integrated Martian logistics network. Tesla operates as a research lab for the closed-loop life support and high-density battery systems required to survive in an atmosphere with zero oxygen. Starlink's current satellite architecture provides the framework for a high-bandwidth orbital mesh network, which is essential for maintaining a continuous data link with a Martian colony. The Boring Company develops heavy mechanical systems needed to drill underground. These structures provide the primary shield against lethal space radiation for early inhabitants. SpaceX completes the system. It is the heavy transport pipeline designed to carry this entire corporate ecosystem into deep space. Reaching Mars requires crossing a 55 million kilometer void. Because of the planet's relative orbits, a launch window opens for only a few weeks every 26 months. This orbital map shows the Hohmann transfer orbit. A rocket cannot fire directly at Mars's current position. It must follow a curved path to intercept the planet 7 to 9 months in the future. Moving the necessary cargo requires the SpaceX Starship. At 123 meters tall, it is the only fully reusable vehicle with the capacity to ferry over 100 metric tons of equipment across the interplanetary gap. SpaceX recently prioritized the Moon as a critical testing ground. A 3-day transit allows for the rapid iteration of vacuum-sealed manufacturing and life support systems before committing to the multi-month Mars voyage. This lunar phase serves as a proof of capability. Success here demonstrates to investors that the logistics of deep space survival are viable, securing the capital needed for the final jump. The Martian surface is a lethal environment. It combines zero breathable oxygen and -60-degree temperatures with toxic radiation, low gravity, and global dust storms that can block the sun for months. Human survival is impossible without a pre-built industrial base. Biological life cannot be the first thing to touch down. The deployment phase utilizes Tesla's Optimus robots. These autonomous machines are designed to arrive first, building pressurized habitats and fuel depots using local resources like ice and atmospheric carbon. This robotic fleet creates a localized city foundation. It allows the colony to grow and expand its physical infrastructure long before any human arrives. Colonization begins with machines. Human arrival is the final step in a rigorous engineering sequence that relies on a pre-built survival grid. While underground domes provide immediate safety, the long-term objective is terraforming, transforming the entire planet into a living biosphere. This diagram illustrates the strategy for heating the planet. Massive orbital mirrors would reflect sunlight onto the frozen polar ice caps, releasing CO2 to thicken the atmosphere and trigger a greenhouse effect. Biological engineering would follow. Specially designed bacteria would be introduced to consume the released CO2 and convert the atmosphere into breathable oxygen, like trees do. This planetary transformation is measured in centuries. The architects of this plan are building a foundation for a future they will never see. Historically, major technological leaps are met with skepticism until the mechanics of the flight prove the skeptics wrong. The timeline for this mission is a race against terrestrial instability. Geopolitical tension and economic fragility threaten the industrial framework required to leave the planet. This interconnected corporate blueprint functions as an existential firewall. It is the only mechanical system currently being built to bypass the Great Filter. The success of a multi-planetary civilization depends on assembling these blueprints before the window for space exploration closes.